After completing this section, you will be able to explain the building blocks of GSM network, mobile station, base station subsystem and network switching subsystem. Explain different network elements and their key functionalities. Define GSM standard interfaces. The GSM network architecture, like any other mobile network, consists of three key components. User equipment called mobile station or MS. Access network, which is called base station subsystem or BSS. Core network called as network switching subsystem or NSS. They work together to provide connectivity, mobility and services for mobiles. The interface between mobile station and base station subsystem is called AIR interface, while the interface between BSS and NSS is called AuC interface. Mobile station or MS is a generic term for the user device. It is a combination of mobile equipment or means subscriber identity module or SIM card that stores subscribers' data. Mobile equipment is identified by International Mobile Equipment Identifier or IMEI. In the GSM network, SIM card identifies the user. It contains the subscriber's identifier, referred to as the International Mobile Subscriber Identifier, IMSI. It also contains information needed for network authentication and ciphering. SIM card is a detachable card that can be placed in any compatible device, thereby allowing any subscriber the ability to use any phone. This allows the separation of the subscriber identity from the mobile terminal and its capabilities. Base station subsystem is responsible for managing the radio network and is controlled by an MSC. Typically, one MSC contains several BSSs. The BSS consists of the following elements: Base Station Controller or BSC, Base Transceiver Station or BTS, Transcoder or TC. Several BTSs are controlled by BSC and transcoder is physically located inside BSC. BSC is the central part of BSS and it controls BTS and TC. It provides much of the radio-related intelligence such as radio resource management, in which it controls the allocation and deallocation of radio resources on the BTS. It is also actively involved in mobility management aspects such as location tracking and handovers. The interface between mobile and BTS is referred to as AIR interface, also called interface. BTS talks to BSC over a BIS interface. BTS maintains the interface. It takes care of AIR interface signaling, ciphering, and speech processing. Transcoder converts speech from one compression format to another to enable communication between BTS and the fixed network where the speech compression formats are different. Network switching subsystem contains the network elements such as Mobile Switching Center or MSC, Gateway MSC or GMSC, Home Location Register or HLR, Visitor Location Register or VLR, Authentication Center or AuC and Equipment Identity Register or EIR. Most of these network elements are logical entities and physically can coexist depending on operator preference. Main functions of NSS are: Call control. NSS identifies the subscriber, establishment and termination of call. Charging. NSS collects the charging information about a call and transfers it to the billing center. Mobility management. NSS maintains information about the subscriber's location. Signaling enables interface with the BSS and PSTN. Subscriber data handling. NSS provides permanent data storage in the HLR and temporary storage of relevant data in the VLR. Let us now look into various NSS network elements in more details. Let us begin with MSC. MSC controls the BSC over the A interface. Typically, in a network, MSC controls multiple BSCs. MSC identifies the origin and destination of a call, mobile or fixed telephone, as well as the type of a call. MSC is responsible for call control, BSS control functions, interworking functions, charging, statistics and interface signaling towards BSS and interfacing with external networks. An MSC acting as a bridge between a mobile network and a fixed network is called a gateway MSC or GMSC. GMSC participates in mobility management, communication management and connections to external networks. VLR is a temporary database which contains information about subscribers currently being in the service area of the MSC. The name VLR is misleading. At any given time VLR will contain subscriber records for both the roaming subscribers and the home subscribers. All subscribers must be registered in a VLR in order to use the services of the network. The VLR carries out location registrations and updates. It means that when a mobile station comes to a new MSC serving area, it must register itself in the VLR. The VLR is normally implemented on the same hardware equipment as the MSC and the two are commonly referred to as the MSC VLR. The VLR tracks the mobile within a geographical area defined as a location area. The Home Location Register or HLR is the central database that contains the master copy of the subscriber records. Information in the HLR contains a subscriber profile which includes information such as calling privileges, account status and the current VLR of the subscriber. The HLR tracks the mobile at the MSC VLR level. An HLR contains a record for every subscriber subscribed in its network area, regardless of his or her current location. Each subscriber has exactly one HLR entry in the GSM network. Authentication is a set of procedures used to validate a mobile station. These procedures protect the network from unauthorized access. The Authentication Center, AuC, is the database that creates and stores authentication information for subscribers. An AuC entry for subscriber is created/deleted along with its HLR entry. Therefore, there is exactly one AuC entry for each HLR entry. Equipment Identity Register or EIR maintains mobile equipment identity-related security information. It performs International Mobile Equipment Identity (IMEI) number checking. This is an optional procedure. In typical implementations, Authentication Center and Equipment Identity Register are located in the HLR. The GSM core network consists of the MSC, GMSC, HLR, VLR, EIR and AuC. The GSM-MAP standard is used for signaling information exchange on the interfaces between core network components. GSM-MAP uses SS7 stack, TCAP, SCCP and MTP For transport, SMS and circuit switch data are the two forms of data supported in GSM today. The circuit switched network in GSM provides access to packet data. There are many limitations when packet data services are provided using a circuit switched network. We shall explore some of these limitations that necessitated the introduction of General Packet Services, GPRS, technology for access to packet data networks. This completes the module. Click Next Topic from navigation menu.